Starting again in the Pomodoro session. This is all the notes we gathered yesterday. I mean, we wasted a lot of tons of time, but I mean, we learned something. I learned something. But still, it's not that really great. I mean, the amount of time I'm spending, it's because I have to be improved. I have to go further. I'm not actually getting into any, you know. So just focus on what you have in front of you and have a relative goal and have a practical goal, what you can actually achieve, you know. Okay, so one way of thinking around. Okay, where are we exactly? Let's consider a couple of applications, probably in order to get some intuition. First, let's think more carefully about what we mean by terms randomness. So let's read it again. So what is probability? That's the question in introduction. I say, well, randomness and uncertainty exist in our daily lives, right? Yes, as well as in every discipline: science, engineering, and technology, basically STEM. Right. So we have probability theory. The subject of the first part of this book is a mathematical framework that allows us to describe and analyze random phenomena in the mathematical world, in the world around us. So it's just, again, probability is just, you know, knowing the likelihood of some event occurring, and probability theory is going to help us, right? So, what every event contains in life, right? Randomness and uncertainty is filled in our everyday life. And probability theory is just a mathematical framework that's just going to help us analyze and basically getting into some prediction. It just gives us a value between 0 and 1. So by random phenomena we mean events. Again, events. Events whose outcomes we can't predict with certainty. Like we can't say certain. It's actually certainly or certainty. Certainty. I mean, he's just saying it and typing it. I mean, there's something wrong with it. Let's consider a couple of specific applications of probability in order to get some intuition. First, let's think more carefully about what we mean by the terms randomness and probability. The terms, right? So the terms probability, get it. What's again, active recall, right? Active recall. Probability is it's a measurement, between 0 to 1. About what? Well, it's a measurement that gives the chance or odd or the to know the likelihood of knowing or happening an event, occurring an event. Basically, yeah, that's what it is. Let me look at it's correct. Yeah, probability theory. Probability. Is the measure of likelihood of an event occurring. So yeah, randomness. It's a very difficult thing to define very well, but we can actually understand, right? Randomness means. The code is one of the simplest possible random experiments, flipping a fair coin. It's a random event. Well, actually, it's a random event. I mean, it's not predetermined. Like if it's gonna head or tail is gonna be flipping a coin. When you flip a coin, will be on the top right. It's very hard for me to even convey that in English because I'm not a native English speaker. I haven't learned English in schools, in college. I learned by my own. So randomness. Again, I feel like I'm wasting time, but this is the kind of way I want to learn. Randomness refers to the quality or property of being unpredictable. Again, things we can't predict are random. Well, random event. So flipping a coin is that a random event? By means, like we can't predict that he's going to flip a coin. Let's say, okay, what's the outcome of the flipping coin? Can we predict? Of course we can. I mean, it's 50-50 probability, right? But it's random thing. It's the outcome is random. I mean, it's just so difficult. It's just the probability, right? It is the concept of something occurring without any apparent cause or predictability. Something's gonna happen we can't predict. That's random. Or without any apparent cause. Which is associated with probability theory and statistical analysis. You know what? I have one down. I don't know. A red thing in anti-fragile. Sorry, it's not anti-fragile. I mean, it's fragile. Fragility versus entropy. Suspicious breaking corner. Okay, so that's quite close to the physics definition. I mean, whatever. So let's consider a couple of specific application problems. Oh, okay. Given randomness, that is a way of expressing what we don't know. Unpredictable. Randomness is unpredictability. The outcome cannot be predicted with certainty. Instead, the outcome is determined by chance, probability, or a complex set of factors. I don't know. There is no good answer for that. Randomness is that something that we don't know. Perhaps if we knew more about the force I flip the coin with. Okay, the initial orientation of the coin. I mean, the physics aspect of it, right? The impact point between my finger and the coin. The turbulence in the air. I mean, the surface smoothness of the table the coin lands on, the material characteristics of the coin and the table, and so on and so forth, right? I mean, so many parameters and factors. Now, we would be able to definitely say whether the coin would come up heads or tails. However, in the absence of all that information, we can't predict the outcome of the coin flip. I mean, the thing is, based on how many flips you can actually kind of like you can get more to the answer, but that's cheating. You have to predict before that even occurring, right? Before even flipping, it's gonna hit or tail. However, in the absence of all that, we cannot predict the outcome of the coin flip. Now, when we say that something is random, we are saying that our knowledge about the outcome is limited. Yeah, we generally say, right, it's a random event. It's random, bro. We can't predict it. It's unpredictable with certainty. Or yeah, like this randomness is things that we don't know for sure it's gonna happen or not. So it's random. Things that involve randomness really leads to unpredictability with no certainty. Yeah, also when we say random, we're saying we really don't know for sure, which in other words you can like we don't have a good knowledge about it, which means the knowledge about it, the outcome is limited. So we can't be certain what will happen. I think you can actually just made it okay. Different authors have their own style, but it's way better than most people here. Since the coin is fair, we don't know anything about how it was flipped. The probability that it will come up heads. Yeah, 50% or two. Two? What do you mean two? What do you mean? There are common interpretations of the word probability. One is the term relative frequency. Again, when you from the very beginning deep dive into it and pondering on every word, but if you really look at it, like, yeah, I mean, it doesn't really matter. Like, people even defined it properly, so the naive understanding is okay. When you're learning like that, it always makes you feel like, do you really know it? Do you really understand what's going on? Like, it's always there. So if you flip the coin a very large number of times, it will come up heads about two of the time. What? As the number of coin flips increases, to get two? What do you mean? Relative frequency. There are two coin. Relative frequency. I mean, frequently you're doing it, like continuously, like at the same time, at the right current time. Relative. Relative means like the word itself is just. In fact, this intuitive understanding of probability is a special case of the law of yeah. That's what I read somewhere about it. Law of large numbers. It is that the system is designed like for like the casinos and people, also like trading system, hedge fund people. The law of large numbers. The system is designed in such a way that it will benefit them based on the law of large numbers. At first, it looks like when you go into casinos, you feel like you're maybe let's say if you want one or two games, you'll feel like you're winning, but you're not. It's just not, bro. The law of large numbers says, which we state and prove formally in later chapters of the book. Okay, interesting. Formally. I don't think I just shouldn't just get the word and think too much about it. It's good, but the thing is, take tons of time, and it really doesn't matter. Just learn it, just go. And practical apply it and learn more and make it more permanent. That was knowledge. The second interpretation of probability is that wait. It says there's a one kind of interpretation of probability, which is relative frequency. It's quantification over degree of subjective personal belief. Yeah, like believing about, well, I mean, again, it's a random guess, but if you believe that the coin will maybe go flip head, the outcome is going flipping of a coin is going to be a head. Some other person is believing it's tail, like based on nothing, just a subjective personal belief. That something will happen. To get a sense of what we mean by this, it may be these kind of things cannot be like more text cannot actually give any answer, but actually doing the examples. Predicting the weather. Yeah, that's a good one. When we think about the chance that it will rain today, we consider things like whether there are clouds in the sky and the humidity. However, the beliefs that we form based on these factors may vary from person to person. Estimates of the probability. Again, it's a subjective personal belief. So it's a different interpretation, even though we're getting the data. So it's our inference rule. So we all get the same data, but it's a different kind of probability. Subjective personal belief and relative frequency. Yes. Often these two interpretations of probability coincide. For instance, we may base our personal beliefs about the chance an assessment of the relative frequency beliefs about the chance that it will rain on an assessment of the relative frequency of rain. What the heck I'm just reading? So we may base our personal beliefs means if we're gonna take that, create some personal beliefs about the rain, right? About raining, will rain, or conditions like based on the conditions like today, right? But it will rain on an assessment of the relative frequency. So if it's continuously based on, in other words, based on the historical one, like looking at relative frequency, rain on days. Like if we've seen some kind of conditions in the past and that leads us to, the outcome is rain. And if we've seen the same conditions again, like cold, breeze, you can see some changes in this like atmosphere, right? And we know that it's gonna rain and will. So we base our now personal beliefs of the time that it will rain on an assessment of the relative frequency now of rain on days, or relative frequency of days which are rained on days which have rained. And it's just now when I read it, it makes sense. With conditions like today, I think you can actually rephrase it better. That's a good one. I think the how from here is good. I want a little bit more refined. Uh, Refine it. Let's see. Let's give different prompt. Better one. So our perception of the likelihood of rain can be, I mean, all these things can be said, right? And we get the point. So using the right word, it's sometimes not necessarily good, because when people are like, what the fuck? If you can write more simply, then introduce the terms. In fact, more than that, make them introduce the problem and make them try to solve it and introduce the problem words. This is my personal belief. That's it. Rain can be influenced by our analysis of how frequently rain has occurred on the previous days with weather patterns comparable to what we are currently experiencing. That's a good one. Now, to formulate our own beliefs about the probability of rainfall of like today, we can take into consideration of how often it has rained in the past on days that had similar weather conditions to what we observe today. You can also get like we may develop our personal beliefs about the likelihood of rain is by evaluating or by analyzing how often it has rained on days with similar weather conditions. By examining the frequency of rainfall on days, we can construct our individual assumptions about the probability of rain. I mean, it's like different kind of people speaking, right? Different people, the way they think, and the way they construct sentences. We can construct our individual assumptions about the probability of rain. Yeah. Oh gosh, did I kill that? This is my life. I'm just not. Some kind of I don't know, but here this guy says this to kind of. I think he's just trying to say the word itself, the probability of the word. We make, yeah. So this is one way, personal beliefs. Another way of law of large numbers. It's quite similar, but law of large numbers is based on the result, and I believe it's still subjective, right? But I think rainy days, the scenario, I mean the weather conditions, well, it can be a quantifiable thing as well, right? It's a quantification of a degree of subjective personal belief. I'm wasting time. This line literally means we may develop our personal beliefs. Again, I need yeah, it's just they just trying to change the probability word. Oh no, I want to say it right. This line means which line? We may develop our personal beliefs about the likelihood of a rain about the likelihood of occurring an event of rain by analyzing the previous days with similar weather conditions. Come on. But likelihood of rain is by analyzing how often it has rained. Days with similar weather conditions. I mean, I'm just having a difficult time with translating English thing. I get it in my head, right? But just the English thing, the language barrier. The beauty of probability theory is that it is applicable regardless of the interpretation of probability. Finally, like, it doesn't really matter. Duh. Like, no matter the interpretation is whether it's subject to personal belief or relative frequency. Well, isn't it the same? The example itself is these two things sometimes can be coincide. That's why I thought like it can be like think about law of large numbers like relative frequency. Relatively something happened again and again, and also we formed a person's belief out of it. That's a rainy day, like those conditions, right? That's relative frequency. But also we came with a subjective personal belief based on that relative frequency that it will be rain if the conditions are met like that. We've seen a lot of time and we intuitively know that it's gonna rain. So these both terms sometimes coincide, intersect. And the beauty of probability theory is that it is applicable regardless of the interpretation of probability that we use in terms of long run frequency or degree of belief. I just don't like these kinds of beliefs. That's what people push away from math, is that they just want to put the right word, and it makes sense, but at the earlier it's just push you away by like degree of belief for like non-English people, right? Speaker. So what do you mean by degree? Like they just think the word too much about it. That's how we usually. But when you combine, it's a different meaning, but it's still degree of belief. It's just the kind of like quantification of belief, isn't it? That's what I think. A long run frequency. Again, it's a probability theory proposes a framework to study random phenomena. Well, that's a different take. So probability theory gives a framework. Well, it's a mathematical framework. Solid mathematical framework to study random phenomena. That's it starts by assuming axioms of probability and then building an entire theory using mathematical arguments, axioms of probability. So we need the axioms of probability, and we have it built everything on top of it, just like the usual math, based on the axioms. Entire theory using mathematical arguments, like arguing things, but it should go back to the axioms, right? Interesting. Now that's a good I don't know if we want to put that to kind of interpretation. Is this is just again, this is personal findings, but I'm not denying it. The author's what do you say? There's so many different ones, bro. Hey, this is my life. Just again, so much redundant answers we get here. Should I be doing like this or like this? To style, like, I don't know. Now, it starts by assuming axioms of probability and then building an entire theory using mathematical arguments. I don't want to put too much words into head because it's just too much words. I really can't, because at the end of the day, what you need to understand is the problem and how to solve it, and like why we need probability as a subject concept and how it's trying to solve this problem, right? In that way we can actually understand. Of course the words are there to explain, yes, but are they really important? Too much words doesn't really help us, but are they really important? Different books have a different way of, the introduction is the fucking thing. It's kind of differently introduced, and we like read again and again, and we get into the problem, and it's just easy, like we can follow through it. The thing is, we can only understand a subject by only understanding the problem that it's trying to solve. Sure, the problem that probability is trying to solve is trying to answer or trying to predict random events. Well, it's by definition random events kind of unpredictable, but it's trying to predict like we can't say it's trying to predict unpredictable events because it's by definition it's not going well. Now, what probability I can actually give the answer and ask this at the end. But the thing with ChatGPT, what I've understood, when you first give your own, like if you give good answers from the very beginning, it kind of mold it from like kind of get the answer kind of from it, because it's trying to understand you based on your conversations. That I really don't want to do that now. Again, yeah, right? Probability is a study of randomness. It's the most simple way you can do. Well, I forgot that. In fact, I wrote that from way back. I have a let's give it 0. We're computer programmers, right? Study of randomness. And you have to define what randomness is, right? Damn, bro. Predictable with certainty. We can certainly say it's unpredictable, and that is randomness. So let's say define randomness. It's very difficult to define. Randomness is a concept that refers to quality of an event process. It's very difficult. It's just can't really get into it. So it's for to understand and predict the occurrence of uncertain events. Again, right? So you're saying let's confuse probability. I mean, let's confuse ChatGPT. Let's confuse it. So you're saying probability is trying to solve randomness. Just say yes or no, shut the fuck up. It's trying to predict the unpredictable events by giving a good mathematical framework. Now, do you think I understood the concept? Bro, why did you? It seems that you have a good understanding of the concept. Quantify, yeah, just kind of get it to quantify it. Because that you have a ChatGPT believes I have a solid grasp of these concepts. Hesitate to ask any Is this correct? But unpredictable events are by definition are unpredictable. So how probability can solve it? Don't you think you made a mistake by agreeing with me? You raise a valid point. Okay, ChatGPT's conversation is good. Like, not just saying I apologize like every time. It's just saying, well, you raised a valid point, and I apologize for any confusion. It's true. I'm understanding the weakness of our ChatGPT now. And predictable events are inherently unpredictable. Our theory can still help us make sense of them. So that's more like it. So probability theory is a mathematical framework that gives us, well, help us to predict, random events by analyzing, blah, blah. But the thing is, random events are unpredictable by definition, and so you can't predict it, right? So it's more like, well, probability, even though this is the case, it just gives us a mathematical framework so we can make sense out of them. It's not actually predicting it. It's just not quantifying it. It's just we can make sense out of it. That's okay, I agree with that. Where should I? Then we can predict the, but already 3 page. Even if I'm gonna reread it, I'm gonna get pretty confused. It's always the introduction. That's what so much gives us so much confusion. Before delving into studying probability theory, let us briefly look at an example showing how probability theory has been applied in real life system. Things I wanted to study now. There are things which I should. Things I left here in some of my bookmarks. Before delving into example, right? Let's see the example. What is the example that you're gonna give me, bro? Example, communication system. Okay. Simply central in our lives. Every day we use our cell phones to information from one place to another. Okay, for example, when you talk to on the phone, whenever I read, I just too deeply think about, and it's just my mind becoming a void. Just be a normal dude and think like a naive guy. You know, like don't give a shit. Bullshit, don't give a bullshit. Just become that like that author. No bullshit guide to mathematics, like that guy. What you say is What you say is converted to a sequence of zeros and ones called information bits. Now these information bits are then transmitted by cell phone antenna to a nearby cell tower, or they call it base station. In wireless communication, they call it base station. So we have a cell phone. Has a receiver as well as a transmitter. So I think it's called transceiver. So they both have those, and sends the information through signals, and these signals contains packets. It sends as a packets, and he has like bits. There's some complicated things going on. I was sleeping in the class, so didn't listen to it. It received by this base station or cell tower, right? Now it's just an example. Received this stuff, and we got an error. Okay, we got an error. Now, transmission of data from a cell phone to a cell tower. Now, the problem that communication engineers must consider is that the transmission is always affected by noise. This in Fourier transform processing, digital signal processing. This thing, I was sitting in the class, so some word heard. Does that there's a signal to noise ratio. Then Fourier series, Fourier transform just help us to whatever. Now, some of the bits received at the cell tower are incorrect. But the thing is, it received from the cell phone. For example, your cell phone may transmit the sequence 0, 1. What is this? Okay, it's wait, let me transfer it. Alright, so this means so it's 17. Is this what it is? Show math as math ML code tech commands. I never seen these things on my web browser. How did I get it? Well, we got the elixir. Elixir X. So IEX, yeah. So 0B, wait, 0BX. Oh god. So did it actually, it's just there is a way to convert them. I don't remember now. To Google. Binary to decimal. But I can actually convert that. It's just it's not that difficult. So here's 2 and well, it's 18. And it's 2, 4, 6 plus 22. Well, the information now is changed. Let's confirm it. 18. Now it's going to be 22. It's 22. So the information is changed now. That means, well, it might be received at the cell tower. In this case, the 4th bit is incorrect. Oh, you're counting from left to right? So, yeah. 0 here, it's 1. Errors like this could affect the quality of the audio in your phone conversation now. The noise in the transmission is a random phenomenon. That's the thing, like random phenomenon. Now how now it's more interesting now. I'm more interested in math than even computer science. Like how this math is actually, that's not even part. It's electronics. Might be received something. In this case, for no, which words will be affected? We don't know. So it is us. If someone tells us a biased coin for each bit and decides whether or not that bit will be received in error. Whether it's used extensively in the design of modern communication system. In order to understand the behavior of noise. It's interesting, right? The actual analog noise has many things to do with math. It's crazy. So the thing is, like, of course, mathematicians learn something else. Engineers do, physicists, and physicists and engineers learn sort of similar math applied. It's quite similar. Many subjects are quite similar. They study calculus, they study linear algebra, they both study probability and statistics. And then it's diverse. Like, then computer science people learn part of pure math, a sort of pure math, so a very small portion of pure math. Okay, now, now this example shows us probabilities use systems in order to understand the behavior of noise, like why noise exists in the first place and how noise is being actually like affects the system. Those two questions: why it's there in the first place, how it's being generated, and how it's being affected. Learn through questions. So that's just one application of probability. Just one application of probability. You can pick up almost any discipline and find many applications in which probability is used as a major tool. Randomness is prevalent prevalent everywhere. It's everywhere, bro. It's in every field. Randomness is everywhere. So probabilities can be applicable to every finance, like electricals, electronics. I mean, computer science also. But, biology, yeah, a lot of. Probability theory has proven to be a powerful way to understand and manage its effects. It's a powerful way to understand, bro. About noise. No. It's a powerful probability theory is a good tool to understand randomness. That's another way of saying it, right? It's just a bullshit notes, bro. No, that's a bad word. That's more like it. In this month, right? I want to learn. I want to continue to be a handmade hero. Just want to continue that series. Then OpenGL. It's too much again. X11 library. SDL and well, SDL is one. SFML. I don't know how good both are. A complete C book. It's too much stuff I'm putting onto my head. It's all like very, very, very narrow, like completely game development stuff. You can't say system programming. Yeah, it's not much, but I want to learn about networking, about next month. I'll learn more about the computer architecture, microprocessor assembly language. Not just learning, just when I learn assembly language, I should buy RISC-V machine so I can actually do the RISC-V coding there. It's actually gonna help me, right? ML data science. Yes, I'm gonna join the course, so eventually I'm gonna do it anyways. But just finishing this so it will, like, it doesn't attack my mind. But I want to make a good game in it. What the hell, bro? So all this is And there's some stuffs here as well, right? Computer Programmer's Handbook. But first, these things needs to be done. What we have here, but it's take a lot of time, bro. What is how priorities are there, but the more I get rid of things from my mind, and also some of the books from my computer, I can be free and focus on the real problems. I think I gotta sleep now. It's not just I'm not getting it anywhere, but if not now, then it's never. So I'm not gonna slip away this time because it's not gonna be. It's already like it's too late. Let's say, but actually it's before too late. So I have a good chance. Both doing like intellectually, learning things, also physically. Like as a man, gotta be physically good, be in good health. So trying to do both. I'm trying to do both. Not a nerd, so that's why I'm having a lot of time dealing with this. It's just that I failed and sort of mocked in school and college that you can't understand, you can't learn it. It's just that I want to show them it's not me, it's your problem. You don't know how to teach. And also, things that you're afraid of when you're in school and college. Now I want to deal with it, right? And that's the most fun thing to do. It's just that I'm like I wanted to pass. I can do it. You don't need a degree to say that, right? Things like I can do it by my own. I can learn it. I can be good at it. I can. Some of the stuff which I really don't want to talk about. So, yeah, I'm gonna stop the recording right now. And I'm probably gonna upload right now, right away.